Now we're going to move on to this next function, which is bounded between 0 and 2 pi in both the x and y directions. So once again, our domain is a convenient box. First, we will find the volume of the space between our function and the box. So just like with the last problem, we will evaluate the double integral of f of x, y with these bounds on x and y. We see that the answer is 0. So the total volume of the function in this domain is just 0. And this makes sense because the function deals with sine, and we know that sine waves oscillate between positive and negative values and can cancel each other out. So this function probably forms a shape with both positive and negative volume values that balance each other out to 0. Now to find the average value, we can divide the total volume by the area of the box, which is 4 pi squared, and of course we get the answer of 0. Once again, this makes sense since we are working with sine waves. Now we're going to look for local minimums, local maximums, and saddle points. Once again, using the second derivative test. First, we compute all first and second order derivatives, and then we find critical points by setting the first order derivatives equal to 0. As a reminder, a derivative equal to 0 indicates that the function is not increasing or decreasing, so it's kind of like a peak of a hill or a valley. So then we see that our critical points happen when x equals y or when x equals 2 pi minus y. So first we can look at when x equals y. Then we can use some trig identities and see that x has to equal pi over 3, or 5 pi over 3. So then we have our critical points here. Then we can look at when x equals 2 pi minus y, and we see that the only critical point is pi, which we already accounted for in the last step. So now we can plug in our second order derivative values into our function for d. When we evaluate at pi, we get d equals 0, so this test is inconclusive. So to think about this point in a different way, we know that x equals y, so we can look at f of x. Then we can plug in values and see that f of x is positive when x is between 0 and pi, but negative between pi and 2 pi. So the function has both increasing and decreasing behavior surrounding this point, so it must be a saddle point. So for our other two critical points, we can just use the second derivative test, and we see that pi over 3 is a local maximum, and 5 pi over 3 is a local minimum. So now we know information about local max and min values, but we can go further to find the absolute maximum and minimum values. We already found our 3 critical points in the last step, and we see here our 4 corner points. So now we just have to look at the edges of our domain. Just as we did earlier, we can look at each line, plug in either x or y as a constant, take a derivative of that new function, and then set it equal to 0. So then we have our critical points on each line, and we can ignore the ones with negative values because they aren't in our domain. So now finally, we can evaluate f of x, y at each of the points, and we see that the absolute maximum is 3 square root 3 over 2. And our absolute minimum is negative 3 square root 3 over 2. Thus, we are finished analyzing our two functions.